We are asked to compute the integral of negative 7x squared over root 4x minus x squared. So, just from looking at this, we should first consider trigonometric substitution, because if we try to substitute just with x squared, we still have this lone x at the bottom that isn't taken account of. So, let's look at this denominator first, because this is where all the action is. So let's rewrite this as 4x minus x squared. So we're going to try to first complete the square to see if we can get something out of this. So we're going to rewrite this as negative x squared plus 4x, take away 4, plus 4. So this is just equivalent to the above expression. And right now we are going to have negative x minus 2 squared plus 4. This is just taking this and just combining it into 1 x minus 2 squared. So now we can rewrite this in a form that may be familiar to trigonometric substitution. So we have 4 minus x minus 2 squared. So right now we're just rearranging this denominator to put it in a form that gives us a hint of trigonometric substitution. So now, because we have it in this form, we want this 4 to be a 1. We really don't like this 4 here. So we are going to factor it out of the radical. So we are going to have 2, because that's the square root of 4. And here we have 1 minus 1 over 4, x minus 2 squared. And now we have this coefficient here, and we do not like this coefficient here. So what we are going to do is we're going to shove this straight into this square. So to do that, all we have to do is take the square root of that and place it inside this square. So the square root of 1/4 is 1/2. So this is going in here. And now we have it in the form 1 minus something squared. Now, which trigonometric identity does this remind you of? Well, it should remind you of cosine squared x plus sine squared x should equal 1. Now, in this case, it really doesn't matter whether or not you use sine or cosine. If you move one of them to the other side, you're going to get 1 minus something squared. Let's just use sine in this example, just for fun. So we have 1 minus sine squared, let's call it theta, equals cosine squared theta. So right now we are going to replace this stuff with sine. So if I draw this in a different color, you might be able to see the resemblance. We have something squared, 1 minus something squared, 1 minus something squared. So as you can see from this is a perfect substitution. So let's do it. We have 1/2 x minus 2 equal sine theta. So now we have our x in terms of theta. So now we can take the derivative of both sides. Or first, you know what? Let's solve for x. Let's solve for x. So let's multiply both sides by 2 and then add 2 to both sides after. So then we give x equals 2 sine theta plus 2. So now if we differentiate both sides, it might be slightly easier. So we have dx equals 2 cosine theta d theta. So now what we want to do is express our original integral in terms of theta. That's an arrow, by the way. So what we want to do is have our negative 7x squared. So x is now 2 sine theta plus 2. So now we're going to take our 2 sine theta plus 2, and we're going to square that. So right now we are going to focus on the denominator. So the denominator, we've rearranged it into this form. So it's going to be 2 times the square root of 1 minus this something squared. Well, this something, we replaced it with sine theta. So now we have 1 minus sine squared theta. And now, right after that, we have dx, but we calculated dx already. So dx is in fact 2 cosine theta d theta. So now, if we continue to simplify this, we can actually rewrite this top part as 2 squared times sine theta plus 1 squared. And this just makes the squaring process slightly more simple. And that's all over 2 times, so the square root of 1 minus sine squared theta is just the square root of cosine squared theta, which is just cosine theta. So this is cosine theta. And our d theta over here, we have a 2 cosine theta d theta. So these 2 cosines cancel out, these 2 2's cancel out, and we have this nice expression over here. This is equal to, I'm just going to write it down here since I'm going to start a new page soon, negative 28 sine theta plus 1 squared d theta. Now we've simplified our original integral in terms of x into this other integral in terms of theta. So now let's try to solve this integral. So right now I'm just going to bring it back up to the top, and we are going to expand this. So what we should get is negative 28 times the integral of sine squared theta plus 2 sine theta plus 1. And this is all taken with respect to theta. And now we know that sine squared theta, well, we can just find that using the double angle formula. So we know that cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And rearranging this, we can get 1 minus 2 sine squared theta, or by replacing cosine squared theta with 1 minus sine squared theta. And now if we solve for sine squared theta, we get sine squared theta equals 1 over 2, 1 minus cosine 2 theta. So now we can rewrite our integral. So we have the integral of 1/2, 1 minus cosine 2 theta plus 2 sine theta plus 1. And this is with respect to theta. And now this integral can be taken relatively easily. So we have negative 28 times 1/2 theta minus, should be 1/4 sine 2 theta. And then we should have plus or minus, because the derivative of cosine is negative sine. So we have negative 2 cosine theta plus theta. And don't forget the plus c, which is the constant of integration. So now if we simplify like terms, what we get is negative 28 we have 3 over 2 theta minus, here we can rewrite this sine 2 theta is 1/2 sine theta cosine theta, and then minus 2 cosine theta. Now, what is theta? We've gone over this for so long that we've sort of forgotten what theta was. So let's go back and check our original page over here. So if we want to have a record, we can draw this triangle over here, where theta is this angle here. Well, we initially set our theta, sine theta, to be x minus 2 over 2. So we can do that. We can write x minus 2 over here and 2 over here. From trigonometry, you know that sine of theta is opposite over hypotenuse. So sine theta in this case is going to be x minus 2 over 2. And by the Pythagorean theorem, we know that this adjacent side is going to be the square root of 4 minus x minus 2 all squared. But we also know that this is equal to this equation down here, and this is also equal to this denominator. So this is essentially just the denominator. So we can just write that as 4x minus x squared. So right now we can go back to our previous page. So what we should get, if we erase these circles that I've drawn, what we have here is a triangle. And from this triangle, we can figure out what our answer is. So this is slightly obscured. Let me just erase this. So we don't need this anymore. So here we have our triangle. So what is theta? Well, theta can just be the arc sine of x minus 2 over 2. So we can simplify this by writing 3 over 2 arc sine x minus 2 over 2. Well, what is sine theta? Sine theta is x minus 2 over 2. So we have minus 1/2 of x minus 2 over 2. What's cosine theta? Well, it's this square root thing over 2. So we have this square root of 4x minus x squared over 2. Now, what is cosine theta again? Well, it's just the same thing. It's that over 2. So if you multiply that, then that's just going to be the square root of 4x minus x squared, close parentheses, and don't forget your constant of integration. Now, this should be the final answer to your integral in terms of x.